Hello students, I am Mom Rose. If you are new to my channel, please don't forget to hit the subscribe button below and the notification bell for you to be updated on my upcoming videos. Happy learning! For today, we are going to graph ellipse. Before that, we have to remember the features of the graph of ellipse. We have here major axis, the longest diameter in the ellipse, whose endpoints are called vertices. The minor axis is the shortest diameter in the ellipse, whose endpoints are called covertices. The center, which is represented by C, is the point in the middle of an ellipse. Foci is the plural form of focus, represented by F, which is C units away from the center. The vertices, which is represented by V, is A units away from the center, while the covertices, which is represented by W, is B units away from the center. We also have to remember the corresponding graphs depending on the center. If our center is at 0, 0, we have here the following equation. And if our center is at HK, we have here another equation. With this, we are now ready to start graphing an ellipse. Let's start with the first item. 25x squared plus 9y squared is equal to 225. This is in general form. If there are three terms here, that means to say that our center is at 0, 0. Let us now convert this one to standard form. Recall that the right side of the standard form of an ellipse is equal to 1. That means to say we have to divide all terms by 225. Our right side is now 1. Recall also that our numerators in the standard form should also be x squared and y squared. Therefore, in the first term, we have to divide both numerator and denominator by 25 and the second term by 9. So in our first term here, 25 divided by 25 is 1, so we don't have to write it anymore, and 225 divided by 25 is equal to 9. For our second term, 9 divided by 9 is equal to 1, so we don't have to write it anymore in our numerator, and 225 divided by 9 is equal to 25. This is now our standard form. From this, we can now get our values. We have here our center is at 0, 0. Our a squared is our bigger denominator, which is 25. So square root of 25 is equal to plus or minus 5. Our b squared is our smaller denominator, which is 9. Therefore, square root of 9 is positive or negative 3. While our c squared is equal to a squared minus b squared. Substituting the values, our a squared is 25 minus our b squared is 9. That will give us a value of 16. Therefore, our c squared is equal to 16, wherein our c is plus or minus 4. Now, since we already have our center, our values of a, b, and c, we are now ready to graph using the Cartesian plane. Let us first plot our center, which is at the origin. That point is 0, 0. Now, plotting the rest of the points depends on our standard form. As you can see, the second term has a bigger denominator compared to the denominator of the first term. Therefore, this ellipse has a vertical major axis, since our a squared is in the second term. So we have to plot our vertices and our foci vertically. Let's start with A. A is the distance from our center going to the vertices. So we have to count 5 units up and down. So we have here the following points. Our first vertex is at 0, 5, and the other vertex is at 0, -5. We can actually interchange the labeling here of the vertices. It doesn't really matter which one is our vertex 1 and vertex 2. Next is our B. B is the distance from the center going to the co-vertices. So from 0, we have to count 3 units to the right and to the left. That points are -3, 0 and 3, 0. Finally, we have our C. Our C is the distance from the center going to the foci. So from our center, we have to count 4 units up and down. Therefore, the coordinates of our foci are 0, 4 and 0, -4. We can now create our graph using the points of our vertices and co-vertices. This is how our ellipse looks like. This is now our second item. As you can see, this is in standard form with 5 units on the left side. Therefore, our expected center here is any point with coordinates hk. Let us now make this into standard form. For our first step, we have to regroup terms with the same variable, and also our constant should be on the right side. Since 16 is common in our first group, we will be factoring it out, so what's left inside the parenthesis is x squared plus 96 divided by 16 is 6x. For our second group, we have here the common factor of 7, so what's left inside the parenthesis is y squared plus 14 divided by 7 is 2. And since we transposed 39 on the other side, it became -39. Now, for each of our term here, we have to complete the square. Starting off with the first term, we have added here 9. That is because of our middle term 6. 6 divided by 2 is equal to 3. Whatever is the answer, squared it, so 3 squared is equal to 9. As you can see, we also added 9 on the other side, but we also multiplied it to 16 because there is 16 in the left side. For our second term, we added here 1. Again, that is because of our middle term 2. 2 divided by 2 is equal to 1. 1 squared is equal to 1. We have also added 1 on the right side, multiplying it to 7 because there is 7 in the left side. We now have the following squared binomials. For the first term, we have here x plus 3 quantity squared. 3 is taken from our middle term 6, that is 6 divided by 2 is equal to 3. While on our second term, we have here x plus 1 raised to 2. 1 is taken from the middle term 2, because 2 divided by 2 is equal to 1, while our right side is equal to 112. The next step here is to divide all terms by 112 because the standard form of an ellipse has a right side equal to 1. So we have here 1 in our right side. Also remember that our numerators should only be the squared binomials. Therefore, we have to eliminate 16 in our first term and 7 in our second term. To do that, in the first term, we have to divide the numerator and the denominator by 16. 16 divided 16 is 1, so we don't have to write it anymore, and 112 divided by 16 is equal to 7. For our second term, we have to divide the numerator and the denominator by 7. 7 divided by 7 is equal to 1, so we don't have to write 1 anymore in our numerator, while 112 divided by 7 is equal to 16. There is actually a shortcut here. The leading coefficient of the first term will be the denominator of the second term. In this case is 16. While the leading coefficient of the second term will be the denominator of the first term, which is 7. With this standard form, we can now get our values. Starting off with the center, our h is equal to -3. That is because in our formula, that is x minus h. If minus is constant, therefore our h is -3, so that we can arrive with +3. Negative times negative is equal to positive. Our k is -1 because of the same explanation. Therefore, our center here is -3, -1. Now, our a squared is taken from our bigger denominator, which is 16. Therefore, our a is plus or minus 4. Our b squared is taken from our smaller denominator, which is 7. Therefore, our b here is plus or minus square root of 7. Now, to get our c squared, we will be using this formula. Since a squared is equal to 16 and b squared is equal to 7, our c squared is equal to 9. That means to say our c is plus or minus 3. Since we already have our values, we can now graph. Let us start with the center. This point is again -3, -1. Now, before we plot our vertices, we have to take a look at our standard form. Since our a squared or our bigger denominator is in the second term, while our smaller denominator or our b squared is in the first term, then our ellipse here has a major axis which is vertical. Therefore, we have to plot our vertices and our foci vertically. Let us now plot our vertices using the value of a. We have here 4 units up and down from our center. Therefore, our first vertex is -3, 3, and the second vertex is -3, -5. Let us now plot our co-vertices using our value b. That is square root of 7, which is approximately 2.65. Therefore, we have to count 2.65 units from the center going to the left and to the right. So, our first co-vertex here has coordinates -3 minus square root of 7, which is approximately -5.65, -1. And our next co-vertex is -3 plus square root of 7, which is approximately 0.35, -1. Let us now plot our foci using our value of c. That is 3 units up and down from the center. Therefore, our focus here has coordinates -3, +2, and -3, -4. Let us now plot our ellipse using the vertices and the co-vertices. We have here this graph. Special shoutout to my awesome students and friends, Irby Sambaan, Faith Baconga, Anika Tabike, Kim Cloyd Eden, and Chester Coquilia. That is all for today. Thank you and see you on our next video lesson.